This is Brendan O'Mahony from Broma Engineering, and today we're doing episode 7 of our equipment series. And today we're going to talk about my favorite thing, only joking, chillers. Okay, chillers. What are chillers? I really don't like commissioning chillers. It's always a pain. It always takes longer than expected. Hard to get vendors for chillers to get on site for some reason, but we'll go through that as we go through it now. What is a chiller? It's for you as a manager, it's a black box. Everything's a black box. And this is actually, and things go into it. Pipes. Here we have chill water pipework, LV cable. There might be an automatic transfer switch here, and we'll have comms cable to control it or go back to the BMS. I think I have everything there. Pretty simple from that regard. So pipe in, pipe out, LV cable. Might be dual supply into the automatic transfer switch, ATS, automatic transfer switch. Chill water CHW for our acronyms, since we love them. LV, low voltage cable, either in here as well for dual supply with an automatic transfer switch. And pipework. That's all you really need to know. You don't need to know how a chiller works. I had my colleague telling me the last day I had to go to a factory witness test because I need to know how to to commission a chiller. I don't need to know how to commission a chiller. If I need to know, like, if I'm up here, look, here's me, Brendan O'Mahony, and I'm here commissioning the chiller, doing all sorts of things here. Who's going to be commissioning everything else on the job? So the manager is away from this. The person who's going to be doing this, hopefully, is the vendor. If it's OFCI, make sure we're going to level 0 now. So this is pre-con. We're making sure we're scoped properly. The vendor, is it Vertiv, Mitsubishi, whoever? Daikin. Give him nicer legs. Give him a smile. He's delighted commissioning his chiller. So we need to make sure that the scope is covered in the vendor pack. So the client has included commissioning. And then we need to figure out what that means. So as a commissioning manager, everything is a black box. It isn't, but it is. You need to simplify it for your brain, otherwise you're going to get bogged down. So it's a chiller. That's it. That's all you need to know. What does it need? We've already discussed that. Who's doing what is the next thing? In pre-construction, we need to nail that down. If there's scope gaps, we need to tell the client, and we need to raise some sort of a risk or warning. You might even be in a proper contract yet, so raising an early warning probably mightn't be an option, but you need to have some sort of way of informing the stakeholder group or the stakeholder team that there is an issue or a gap. So what do we look for when we look for chiller scope? Well, transport of FWT, factory witness test, factory acceptance testing, is that included and paid for? If not, maybe the client doesn't want it. They surely have to have a factory acceptance test or an end of line test, some sort of test to show that it's leaving the factory. That's a legal requirement in most states in the modern world anyway. So there have to be some sort of documentation to say that the chiller is tested electrically. So that's a electrical standard. Probably want to be pressure tested, all sorts of things that want to be done. But usually, 99.9% of the time, there is going to be a factory witness test required. There's going to have to be a witness team to go there. People are going to have to pay for hotels, transport, who's going, nail that down in pre-construction. Who needs to go, who doesn't need to go. Be very clear. Shouldn't be a debate. It is what it is. Nail it down. Then, transport and draw the truck. Who's moving it? Usually the vendor. Hopefully it's in the vendor scope, make it easy. They're going to put it on the truck in the factory. It's done as testing. It's going to drive to site. And then the route. Is it oversized? If it's oversized, it can't go under some bridges. I've seen stuff arrive on site that's hit a bridge. It's not good. It's going to totally destroy the schedule. You have to send it back or get a new one or get a spare one, and they don't exist at the moment because the industry is so busy. And then delivery, always a problem. Who's doing what now? Who's bringing it into the site? We're doing an inspection, receipt incoming form, the RIF. We can talk about that in another video. There's no point going into detail here. I think we have one done already. Who's lifting it off the truck? Who's moving it in? Where is it going? Do you need a crane? Etc, etc. Is the vendor doing all that? It could be included in their scope. Sometimes it isn't. Sometimes no one's thought of it. Sometimes it's a gap. So there has to be a cost and time put against it in the schedule. Okay, just to recap, we have level 0, pre-construction, level 1, factory witness testing, factory acceptance testing. The red tag now is done at delivery, so level 2 is install on site, and level 3 is what people traditionally call commissioning, but I call it energization and testing. It's dynamic. Level 2 is static, as I mean the equipment is static, not the stuff around it. Level 3 is energized and it's dynamic. That's how I remember it. That's the rule. Static testing, dynamic testing. Okay, that's how I remember. Level 2 is static, level 3 is dynamic. Pre-power on, post-power on. Level 4 is the CXA are doing their functional performance testing, and level 5 is IST. Now, the CXA needs to worry about these things, so I'm not going to cover them heavily here. So we're going to finish up at the end of level 3 when we hand over to commissioning. We have a lovely acronym again. Well, it's not really an acronym. At H2C. It's an abbreviation. What's the difference between an acronym and an abbreviation? I'll let you figure that out. But hand over to commissioning, end of level 3, power on, end of level 2. End of level 1, these days is usually set in place. A few years ago it was when it left the factory witness test was complete, but now it's been pushed forward. Red tag, yellow tag, green tag. Green is go. Yeah, but actually it's go here, but green tag means it's ready for, usually level 4 is blue, and usually level 5 is white. There is no tag for level 0. It's a new thing, it's pre-con. So we're getting ready, we're making sure the scope is there. And then sometimes there's a level 6 now, which is handover and, the warranty. We won't worry too much about that either, but you'll have to have your training done. You could consider that maybe level 6, but it's really level 3. So training. So vendor, scope, back to scope. Is there training in their scope? Are they sending someone over to train the operations team on how to run and maintain and troubleshoot the chiller? So that goes into level 0 for planning. We're planning all this. We're making sure it's accounted for financially and time-wise. And then we have to build a schedule based on this. So we've got the equipment now to site and it's been set in place. Who's setting it in place? You need to know, is it going up on plinth? Is it going up on steel girders? Are the holes drilled in the right place? All this stuff needs to be communicated to the structural steel team. You could drill the holes on site with a mag drill, or you could drill them in the fabrication yard before the steel gets to site. Depends on the circumstances. Sometimes one's easier than the other. It depends on the risk. It depends on how much you can adjust the steel and all these kind of things. It's a judgment call. But remember, when that chiller comes, you want it to land properly and you want to be able to bolt it up quickly and move on with the rest of your life. Okay, so now the part that everyone gets interested in, and the part that the older guys and guys who don't know much about commissioning think commissioning is, which is dynamic testing. It's not commissioning starts at level 0, ends at level 6. It's a whole massive process. It's not just turning stuff on and making sure it works. Usually, I don't even need to be there for that. It's already done. The hard work's done. Most of our work is paperwork. It's planning. Most of it's planning. If you plan properly on site, there's not going to be much to do, to be honest. Now, if you're a strong character and you're good at leadership and you're good at motivating people and making sure stuff is done, great, be on site, but most of this job is planning. Okay, so level 2. We have it set in place. We're getting our LV cable. There might be 2 of them. And our chill water pipe work has to be connected. So this has to be designed. Has to be a technical submittal in for it. Has to be approved. Of course, the chiller as well, but if it's OFCI, usually it is. The technical submittal will already be approved by the time you get there. But make sure it is. LV cable need a technical submittal, need to be approved. The lugs, landing should be planned. Colors, right size, manufacturer's approved. So technical submittal goes in for that. You could have a first of kind needed. FOK, first of kind for pipework for the first chiller that's set in place. So make sure your first of kind list is there. Sometimes the quality manager does that, but I think the commissioning manager should cover everything to do with equipment, and everything to do with CSA should be quality. That's the way I look at it these days. So room ready, is the chiller going to a room? So room ready is quality. That's the quality manager. QA/QC usually called. So room ready. Is the room ready to take the equipment? And on top of that, you need a roll-in route. If it is in a room, it usually isn't, but you know, there needs to be some sort of quality control wherever that chiller is going, that it's ready to take the chiller. If it's steel, it might be as simple as the holes are drilled. There's no swarf, there's no debris, there's nothing up there that can be blown in the wind and smash against it. You know, it's clear, ready to go. So what are the criteria for ready? Are we pre-pulling the cables? So the cables are there, you know, give them a little bit longer. You'll be dressing the cables after that. Comms cable could be pulled beforehand. Is the cable tray, is that technical submittal approved? Is the design of the containment, the cable tray approved? The pipework should all be approved, the pipework sizes. Where are the instruments going in the pipework for the BMS, etc., etc. So your stab-in points, positions, do they make sense? Are they accessible? Can people see them? The valve positions, can we move the valves, actuate the valves? Are they accessible? Can operations get there? Do they need a hop-up? Etc., etc., etc. That's all part of the design review. And sometimes this is very late because pipework, you know, it takes a long time before the design is ready for pipework to be designed. And usually that's a contractor design portion, another acronym, CDP. You need to understand that for design scope. The design manager should understand it, but sometimes that doesn't happen. So that is CDP. That's re-before. The end of re-before, this is all done. Everything's done. Everything can be made. We know everything. Reba 5 is construction. That's what we're actually doing on site. So get comms cable. Get everything you can done early if you're waiting for the chillers. Get the cables pulled. Get the pipework installed as much as you possibly can. You need to leave room for some adjustment. If you can use flexis, use them. It's much easier. What else can I say on that? And then next thing will be flushing, which is another pain. Can be sometimes. People are using stainless steel pipework now a lot more. With carbon steel, there's going to be a lot more flushing. So if you use stainless, you're going to save some time on flushing. If schedule is super, super important, which a lot of time now it is, because the end user wants to get in as soon as possible, and there's contractual obligations, and there's liquidated damages that could be imposed upon the developer, which might be transferred onto your company. So be very careful. Okay, so now flushing. We're just talking about flushing with my own teammates this morning on a job that we're doing somewhere in Europe. And what do we have to say about flushing? Everyone talks about flushing at the start of a contract as if we're actually going to be down there flushing. Again, we're only managing. So we need to figure out who is flushing. And you have two options really. It's going to be under the mechanical contractor. So GC. So we have a flushing specialist. Now the mechanical contractor might have flushing specialists within their group, and that's wonderful. So they can do it themselves. Or it'll be GC, direct flushing specialist. Doesn't really matter. It's up to the GC, but that's the chain of command. Direct or directly into mechanical contractor. This is 99% of the time. This would be odd. Okay, so what am I going to say about that? You need a flushing plan. and there's going to be scope problems as always. This needs to be done as early as possible. We need to know where the flushing rig is going. Are we using pumps that are there and servicing them after? Are we using an external rig? What are the flushing velocities? So I would highly recommend a flushing specialist to do this. Costs a bit of money, needs to be included in the scope, included in the cost, included in time. The problem with flushing is it usually is an unknown time. So we need to allocate enough time for it, and we need to build flexibility in the schedule around it. We don't want it a fixed time and then be sitting there for a week doing nothing. So yeah, get the pipework installed as early as possible. What do we need to know about flushing? Which valves are going to be closed? Which sections are we flushing at a time? How many flushing rigs are we having? All that, it needs to be a detailed plan. The client will usually look for it. So don't be surprised. Get it started early as possible. Even get a piece of paper and say flushing plan and put it up there as a document to be completed. Put it on your commissioning document list, and keep working on it. It's a work in progress, because as the design unfolds, things will change. Get your flushing specialist engaged as early as possible, and hopefully it will go well. Flushing nightmares. Sometimes people sabotage pipework. It's very important that the pipework is protected, that people can't drop nasty stuff in there. I've seen it many times. When people are unhappy, they can throw things into the pipework, and then it upsets the flushing and it takes them a lot longer and clogs up things and damages pumps. So just be aware of that. It's something, it doesn't happen often these days. It happened a lot more in the old days, but it happens. Anything else on flushing? No. So you'll need a flushing report as part of the end of level 2. That'll be part of your yellow tag. So remember that. You need a report as well, and include it in the flushing specialist contract. Okay, so then we need electricity to turn it on. And flushing and filling is also part of flushing, so that needs to be part of the plan. What are you going to fill it with? How are you going to fill it? Where are the high points? Identify them on the drawings or a model, or take a snapshot of the model. Prove this is the high point. We're filling it right up to the top. There might still be water in. There might still be air in there, so you might have to refill it. Hopefully there is. What's the word? Sometimes I can't think. The machine that takes the air out of the line. Sorry for that. We need to test the LV cables coming to the chiller, and we need to know where the board is down upstream and where the board is above that. Might be the main switchboard on that string. There might be 2 supplies, so be careful. There'll be different strings for redundancy. There might be an ATS, automatic transfer switch. That'll have to be commissioned also. There'll be breaker settings. You'll have to talk to your electrical colleagues, or the electrical team need to know when they'll have the upstream boards ready, so they can cascade power down to you. That needs to be scheduled. In the morning meetings, as if you're mechanical, you need to be asking, when are we going to get this done? Are we on schedule? Are we on schedule? Go down and have a look. Talk to the guys in the field if you want to. Make sure the cables are there. Make sure the schedule is being held. So, walk the site if you're on site and just look, see, does it look right? Ask people. Don't feel foolish. Just ask them to explain it to you. So the cables will have to be tested, and then they'll have to be torqued. So once they've tested the cable, and we'll do another video on that, they'll have to torque each end and put a torque mark on the bolt that's holding the cable to the supply in the chiller. They'll have to be cable labeled. Sometimes that can hold up a tag. You don't want that. Make sure that's done. So the electrical team keep asking. And we'll do another video on specifically on cable testing, because it really does hold up jobs. Because until that cable is tested and you've got the test sheet and it's up against the asset, and we can prove it's tested, marked, the right color, torqued, They might even need pictures. Make sure you understand the scope, what the client needs. You're not going to get your yellow tag, and then you're going to hold up the job. Okay, the next thing is BMS. You need to make sure your BMS cables, your comms cables are connected, tested, ready to go. Be back into your BMS panel. There'll probably be a BMS panel on the chiller, and then there'll be a BMS panel up there somewhere, and then back to the head end. So talk to your BMS manager, make sure they're on schedule. The morning meetings, talk to the BMS, has to be asked, are you on schedule? Go down and walk it, make sure. They might tell you it is. The BMS contractor needs to be on the ball. So driving the schedule every morning with project controls, making sure we understand what's done, what's not done. We'll talk about a detailed schedule in another video, but that's how we measure it. So we have a percentage completion based on all the little tasks. We don't just have big, massive tasks that go on a week. The longest task possible can be a day. So that's how we do a micro schedule for a chiller. It's day-tight compartments. Okay, I won't talk too much more about BMS, but that has to be done for your yellow tag. So next step is power on. And there should be a meeting the night before or that morning, depends how many you've done, but what's being powered on today, the senior appointed person and his team, the appointed people, they're in charge of switching. They'll have to have a switching plan that's done ages ago, but today should be on the schedule. Today we're turning on chiller number 6 and chiller number 7. The site appointed team tell you when they can. So is it going to be 11 o'clock, 12 o'clock, 1 o'clock? What are they doing in the morning? What are they doing in the evening? It's got to get turned on today. Health and safety needs to be involved so that that area is cordoned off for power on. Usually health and safety should be up there. Might be a permit to work area at this point. There might be power in there already to other chillers. Yeah, so power on's pretty simple once everything's good. And then the vendor is free to do their level 3 testing, which they'll run through all their test script for level 3. And then you'll have to do your load testing. This is more and more going to level 3. I don't think load testing is level 3, by the way, because that is FPT. That's functional performance testing, load testing. That's technically what it is. So really load testing shouldn't be done till level 4. But these days we're doing load testing in level 3, which now is under the GC scope, and the GC are not specialists at this. So now you've 2 teams of specialists coming in, one after the other. Is that efficient? Not really. So what's happening then is, for level 3, we're doing a level 3, level 4 combined, but it's the GC are still holding it, which I don't think is fair. When it's functional performance test, that's a specialist job, and CXA all the way from me, and that's the way developers should scope it. It can't be looked at any other way. It's functional performance testing. If you need load, you're testing its functionality. That's what it is. That's the way it's called. That's the rules. We're changing the rules now because we think we're smart, but we're not. So it's just my little gripe on level 3 for the moment. The load bank plan as well should be with the specialist CXA. Shouldn't be on the GC. The GC is just commissioning management. We're not specialists in load bank planning. I used to be CXA, so I can do it, but that should not be. The load bank plan, every day of the week, is CXA. And now I see it all the time, it's in the GC scope. Why would the GC be doing a load bank plan? If someone can put that in the comments, please let me know. Why wouldn't the specialist that you've hired, who's done hundreds of these, why wouldn't they be doing it? And they know what load they want to do their functional performance testing. So this is where I get a little bit annoyed with the industry right now. This level 3, level 4, combining it, the CXA sit back and drink tea and eat biscuits while the GC is out there running around, who's already extremely busy. Load testing level 4, call it level 4. If you can get hold of it, if you can start level 4 before there's a milestone of handover to commissioning, do it. It should be handover to commissioning dates for each separate piece of equipment. It shouldn't be one line across the whole project. It doesn't make any sense. Some systems are going to be available for level 4 before others. It shouldn't be one hard line for the whole project. It doesn't make any sense. You're just slowing yourself down for no reason. It's not going to help anyone. So that's just my little gripe for today on level 3 and level 4. But let me know what you think, because it's important that the industry straightens itself out again, and that the right people are doing the right job, so we can speed things up. That's the whole point, isn't it? So we can hand it over to the end user and they can start running servers or GPUs as soon as possible. That's what everyone wants. So why mess with systems that work? Okay, anyway, level 3, level 4 is going to get done. Spare parts, make sure there's loads of spare parts. Either in the factory with the vendor, they can ship out quickly, or they're there on site. Things do break, things burn, things get damaged. Yeah, and critical snags, make sure nobody puts up a critical snag that isn't a critical snag. A critical snag is only something that can damage people, which is very important, and equipment. Anything else is not critical. So when you're defining critical, you need to make sure that somebody isn't saying, oh, the panel got dented, it's a critical snag, we can't go on without fixing that. That's untrue. So make sure you understand the contract and understand the scope around here, where everybody's getting very crazy and there's pressure, there's stress, it's the end of the project, people are getting kind of nuts. You know, you want to understand your scope, understand your contract. And if you ever need help with that, we can look through them, we're used to it, we can pick out problems very quickly and make sure the person who's supposed to be doing their job is doing it. I hope that really helped. So until next time, please leave comments, like and subscribe if you haven't already, and see you next time.